In this tutorial, we're going to go over how to create a drawing in Fusion 360, and we're going to be using the Titan 9M as our model for this. Very first thing that we're going to do is let's check out the Titans of CNC drawings, and this will give us an idea of what our drawings are going to look like. Sheet number 1, we've got the outside profile of our part, and if you look closely here, they have some construction geometry that helps lay out the outside of the part. Sheet number 2, we've got our location of our counterbore holes, and we also have this revolved cut. Sheet number 3, we have these irregular shaped pockets that follow the outside of our contour, and then we also have this big counterbore in the center of our part. Let's jump over to Fusion 360 and create this part. I'm over here in Fusion and I already have my part loaded up. Very first thing that we're going to do before we jump over to our drawing workspace is we're going to create a sketch on the top of our part. We're going to go to Create and Create Sketch. We're going to click on the top of our part here. Now that we have a sketch on the top of our part, we're going to open up our previously designed sketches, and I'm going to turn sketch number 1 on. Notice we see a little bit of geometry appear, and we'll better see that if we turn the visibility of our bodies off. The geometry I want to choose from our sketch number 1 is this line, this construction circle in the center, and then this circle here that's tangent to these outside circles. So I'm going to go P on the keyboard, this line, our construction circle, and I'm also going to choose this circle, and then press OK. If I turn sketch number 1 off, you can see the geometry that I chose for our new sketch. We're going to finish our sketch, upper right hand corner of our toolbar, and then we'll turn our bodies back on. Before we move into our design workspace, we have to save our part again. And then we're going to change our workspace into the drawing workspace. In our pop-up window here, it's asking, do you want everything in this workspace to be a part of your drawing? Yes, we do. We are creating a new drawing, and the template we'll be using is a template that we created in another video that you can watch. We are using sheet size B here, and then we're going to press OK. The very first view that Fusion 360 wants us to land is our front view. We are going to change the scale of our front view to a 1:1, and we are going to turn on tangent edges here. I'm going to land this view about this location here, and then press OK. Notice one thing, we are also seeing hidden lines appear, so we're going to double click on it and go from visible and hidden just to visible. And that will just give us the outside profile of our part. Now that we have our front view landed, we're going to add in some other views. We're going to go to projected view. We're going to click on our front view and drag our mouse up, giving us a top view. And then we're going to drag our mouse over to the side, and that will give us an isometric view. And then press enter. We're going to change our isometric view from a wireframe into a shaded part. Double click on it, and we're going to choose shaded with visible edges, and then we're going to close that out. The next view that we're going to create is a section view. We're going to create this section view off of our top view here. So drawing views down to section view. we're going to click on our top view as our reference view. We're going to start concentric to the center of our bore. I'm going to left click, and then we are going to land our section line right about the center of this web here between our pocket and our counter bore, and then press enter. Our scale that we're going to use on this view is going to be a 2:1 scale. And we're going to drag this view down towards the bottom, right about here, and then press OK. Now that we have our 3 views landed, we're going to start adding some dimensions to them. Let's start with our front view here. Our front view, we're going to use this to show the profile that you spin around using a revolve cut. So we're going to go over to our sketches here. And I'm going to turn visibility of sketches on. And my revolve cut so happens to be sketch number 3. And you can actually see that revolve cut up here. Yours may be a different sketch, so please sort through your sketches and just show the visibility of sketch of that revolve sketch there. Now that I have my revolve sketch present, I'm going to come in and add in some geometry here, and which will indicate that is the center location of my part. I'm going to go up to geometry and down to center line. I'm going to click on these visible edges on the outside of my part. And then I have this center line up here. I'm going to drag this grayed out arrowhead, and I'm going to reference off of an endpoint on the top of our part and drag it to the center here. And what that did is it landed our center line exactly on the top of our part. This is a good way to reference off of when you're using ordinate dimensions. With that in mind, I'm going to go to dimensions, down to ordinate dimensions, and I'm going to reference off of the top there, dragging my mouse up, and then I'm going to reference off of another endpoint on the top of our part, and I'm going to drag my mouse over. Before we proceed, one thing I want to change here is our annotation settings. Bottom center of our workspace, you'll find your annotation settings. I'm going to turn on display trailing zeros, and then I'm going to change my linear dimension precision to the thousands column. With that in mind, I'm going to come back and change the primary precision of my datum locations by double clicking on them and setting them to 0. I'm going to do the same over here and set that to 0. Now that I have my 0 location indicated, I'm going to add in the remaining balance of my measurements. I'm going to reference off the top of our part here and drag my mouse up, and we're going to reference off of the extension line coming off the 0, and then off the bottom, same thing, referencing off that extension line, just like that. Now that we have our vertical measurements stated, we're going to come in and land our horizontal measurements off the part, and then we're referencing off of our extension line from our 0. That way everything lines up perfectly. This next measurement, we're going to have to really zoom into this sketch that we turned on. We have a radius here, and what we want to do is we want to find the intersecting point of that radius, because that point is really necessary when we created our sketch. So we're going to click on it. Again, referencing off of our extension lines. Then we're going to come in at the top of our part, right at this corner. And that is the top of our part. I'm going to clean up my workspace a little bit. I don't like the fact that this line is passing through that other line there. So I'm going to go to Dimensions and Dimension Break. And I just added in a break here. We can do the same with the 3-inch one. And I believe it broke it, but the issue is we have our sketch there, and that's why it's acting weird. We're almost done with our front view. A couple other dimensions we need to state on here. The next dimension that we're going to state is this angle coming off here. We're going to go to Dimensions, down to Dimension, or D on the keyboard. We're going to reference off of this angle and then off of our center line. And we're going to drag this out like this, indicating that that is 75 degrees. While we're here, we're going to zoom back into that radius that made up our revolve cut. And we're going to drag that down here, like so. Our front view is pretty much done. I'm going to move up to our top view now. Our top view, we're going to kind of set it up very similarly. We're going to go to Ordinate Dimensions. We're going to set our datum location right in the center, like so. Actually, excuse me, our datum location is not going to be in the center on this one. That's all right. I'm going to move some things around before we proceed. I'm going to move our front view down. And then I'm going to delete this datum. Our datum on our front view is actually indicated right off of the upper left-hand bolt hole. We're going to drag that up, and then we're going to drag this up and over so we avoid our section lines here. I'm going to alter the primary precision back to 0 on both of those. And if you need a little bit more room, you can always extend your section lines out here. It's looking pretty good. We're going to go back to Ordinate Dimensions. We're going to set our vertical height of this other bolt holes. Again, referencing off of our extension lines from before. And then right down the center. And I'm going to put a little bend in here just to get it away from our section line. We're going to go right from the center here. Referencing off the top. And then over to our right-handed bolt holes. again referencing off the top. I'm going to right click and press OK. One thing I'm going to do is I'm going to change the length of our extension lines on this, just to kind of tidy up our workspace. There's really no reason for them being that long. And that's looking pretty good. Now that we have our ordinate dimensions landed, we're going to add in some of our other dimensions. We're going to go dimensions down to dimension. The dimension that we're going to look at here is this radius right inside this pocket. Oh. I'm going to cancel that one, go back to dimension. Let's look at this radius here. I'm going to cancel that one also. I'm going to come off the bottom here. That's looking better. So we got our radius here of 255 thousandths. We have our web thickness here. So I'm going to click on our flat edge here, and we have our web thickness. And then I need to put in some diameter measurements. So I'm going to go back to dimensions and diameter dimensions. I'm going to click on the outside here. That will give us a diameter measurement. And then I'm going to click on the outside or the inside of this diameter here. And that will give me a diameter measurement of that pocket. And one thing that we forgot to do on this particular drawing is we forgot to turn on our last sketch. So I'm going to do so now. And notice by doing that, our construction geometry appeared. I'm going to go back to diameter measurement. I'm going to add in that diameter also. And then I'm going to add in the diameters that make up these three circles in the center. The outermost circle, the inside of our counterbore, and then our construction circle. This drawing's looking pretty complete now. I just want to clean up some of the geometry on here, make it a little bit easier to read. I'm going to come in and right click and press OK. I'm just going to organize this a little bit better. Like that. This 1-inch one, I'm going to add a note with it. I'm going to add in construction circle for tangent lines. Notice that's a really long note. So I'm going to come in and hit a backspace and then shift enter. And then close that out. Notice it's kind of overlapping over here, and that's okay. What I may do is I may change the location of this over to here, and then that has its own separate area. That's looking better. It's kind of, and then it's over here where the construction line is. Our next thing is we're going to indicate that this is a construction line and it is tangent to the circle and tangent to the outside. Text with the leader. We're going to click on the line itself and drag our node in. This time we're going to go over to our symbols and add in a tangent symbol. And then type in TYP, indicating that that line is tangent typical to the construction circle, and then also the circles on the outside. Again, you can move these around and kind of organize your workspace as you see fit. We have some radiuses on the bottom of our part that we're going to indicate. And it looks like I'm missing one other circle here. So I'm going to go D on the keyboard, and I'm going to click on this other circle. This is the visible circle, and drag that one out. That one's actually the diameter of our bore. While I'm in the diameter mode, I'm going to click on this radius here. Got a bunch of couple corner radiuses here that are 300 thousandths. I'm going to right click and press OK, and then I'm going to kind of organize my workspace again. I may change this this web here over to this side because there's nothing stated there. So I'm going to delete that one, D on the keyboard, and I'm going to reference off this side. That will help kind of organize things a little bit. Right click, press OK. We're going to put an indicator in here for 4x for our quantity. With our radiuses here, I'm going to drag that in now. There are also 4 of those, so 4x. The radius of our pocket of 255 thousandths. There's actually 8 of those. Close that out. I'm going to reorganize this a little bit. Have those kind of line up with each other. I'm going to jump over here to 750 thousandths. Appears like we've got 4 of those, so 4x. Close that out. This 651 number, we've got 2 of those. 2x. And this 600 thousandths, same thing, we got 2 of those. So all we did is we just updated our quantities on some of these items, and we kind of reorganized them and played around with some of the alignments on things and just try to tighten things up a little bit. So everything's in alignment and everything is easy to read. We're almost done with our top view. I'm going to double click on our ordinate dimension up here and say that this one is typical 2 times, so 2x. Same thing with our vertical measurement, 2x. And we're looking pretty good. I'm going to jump down to our section view now. Our section view, I made this a little bit bigger so we could see our counterbore and definitely see the bottom of our pocket. I'm going to go D on the keyboard for dimension, and we're going to click on the top of our part and then the bottom of our pocket, dragging in a depth. And then I'm going to drag a extension line off of that so we can get that measurement out of that pocket. Back to D on the keyboard. We're going to click on the diameter of our counterbore and drag that up. And then the diameter of our bore and drag that up. And this is just some further clarifications from our top view. In addition to having those measurements here, we're going to add in a radius here. So we're going to click on that radius, drag this down. And then I'm going to put a note down here to further clarify that the bottom of our pocket is following the outside of our contour. So I'm going to go text with the leader. I'm going to click on this line and drag that down and add in the following statement. Oops, I spelled bottom wrong. Bottom of pocket must follow outside profile. Now notice how it kind of runs off into my title block. I can come in and add a return in here and kind of organize that statement, and then I can put a center justification on it to center it up. Notice how this statement's getting kind of close to this. I'm going to move over my section and kind of organize it. Lastly, I want to give some further clarification on the thickness of our part, and definitely the thickness of our counterbores here. Unfortunately, our section view is very close to our title block. So what I'm going to do is I'm going to click on my front view, because that's our base view, and I'm going to drag it over to give us some room here. And notice as I move that over, all of my views move over. That gave us a little bit of room here. I may come in and trim this back a little bit. So let's do that right now. I'm going to click on my section view and drag this back, and that will also give me some added room over here. Now that we've got some room in here, we're going to add our ordinate dimensions in. We're going to reference off the top of the part, landing our 0 location. Our extension lines don't need to be that long this time. And we have our 3 dimensions in. I'm going to change my 0 location to 0 for our primary precision. And that kind of further clarified the depth of that pocket for our counterbore. I'm going to move our section again, trying to organize this a little bit. Again, there's really no right or wrong way. It's just trying to make it easily read. Make our drawing easily read. I'm going to double check and make sure I've got no leader lines crossing over each other. Everything's looking pretty good. almost done. The only thing that we got to state now, right now, is our counterbore, and then we're going to put a statement in for our chamfer. I'm going to do a text with the leader here. I'm going to reference off of our hole. Our hole for our counterbore, there are 4 of them, so 4x, the counterbore symbol, and our diameter symbol. This needs to be 380 thousandths. And then the depth of our counterbore is 250 thousandths. And then the GD and T symbol for the depth. Close that out. While we're here, we can also put in our hole. So I'm going to go Shift Enter again. And then I'm going to put the hole specs in here. The hole is diameter 250 thousandths. And this goes through. We're getting a little close to our isometric view, so I'm going to move my isometric view down a little bit and over. I think the very last thing that we're going to add in here is we're going to add some chamfers. The top of our chamfer of our part on the outside, including the pockets, are going to be chamfered to 25 thousandths, whereas the rest of the part is chamfered to 10 thousandths just to break the edges. So we're going to come in here and text with the leader. We're going to type in 3x 25 thousandths by 45 degrees, and then chamfer. I'm going to move this around just to kind of organize. And again, we're getting kind of close to our isometric view here. I'll move that up a little bit. The only other thing I'm going to add on this is I'm going to add a little statement clarifying what this box is here, because that is our sketch for our revolve cut. I'm going to use a text with the leader. I'm going to reference off of this edge here and bring this down. And then I'm going to type in sketch for revolve cut, enter, must extend beyond edge of part. And I'm actually going to tidy this up a little bit more and then close that out. One thing I am going to do is I'm going to drag my top view up a little bit. And just give my front view a little bit more breathing room. And then I'm going to take my section view and drop that down a little bit. Again, this is just personal preference. I like a little bit of breathing room and all this stuff. That way people don't get measurements and locations mixed up on different views. Other than that, looks like this drawing is fully defined. Somebody else can recreate this part by using this drawing. So this concludes our tutorial on how to create a drawing in Fusion 360 of the Titan 9M.